Hello everyone, my name is Elliot Jones of the 2019 Horizon CDT cohort, and today I'll be taking you through my PhD proposal project, Data Farming, Facilitating Sustainable Intensification in Agriculture through Digital Innovation. I am supported in this project by the Future Food Beacon of the University of Nottingham and the Centre of Improvement of Maize and Wheat, aka CIMMYT. I will be supervised by Martin Flintham, Mercedes Torres and Anne Tabulik. To begin with some context, this project is formulated in response to three of the greatest existential threats to humanity of our era. First, global warming predicts that temperatures will rise by more than 2.5 degrees by 2050, leading to extreme weather events and drought. The population is set to grow to 9 billion people within the same era. This will increase the demand for food by up to 100%. The consequences of these effects will be disproportionately felt in areas which already feel great inequality and poverty. The combination of these three factors puts immense pressure on food and agriculture to produce more fairly, and with the consequences of more heat stress. In the wake of these crises, sustainable intensification has emerged as a key strategy for climate adaptation, agrarian development, and food security. The founding principle is to create more with less ecological and resource cost. As opposed to previous approaches, sustainable intensification strives to put different aspects of human life on the same level playing field. In the image in the top left, we can see that social, human, and environmental aspects are put on the same par as productivity and economic values. The graph below demonstrates the success to date, that while area harvested does continue to grow slowly, total yield has grown much larger since 2007. The two images on the right demonstrate the ideal outcome of such a strategy, with happy productive farmers above and happy impactful scientists below. Sustainable intensification is measured and implemented on a field of agricultural economics known as adoption studies. However, recent literature suggests that this is limited in both methodology and scope and impact. Conceptually, adoption is often treated like a dichotomous variable, with no indication of repurposing or extent of use. Economists rely on binary modeling techniques, which prevent any efforts from gaining any deeper understanding. There is rarely a longitudinal perspective, appreciating adoption over time. There is a clear economic bias for larger, more conventional farms, and adoption is estimated on a very small set of data sets with few attributes to describe it. The result of which is poor data and information for technology developers and NGOs to implement policy. This leads to socially exclusive developments, unattainable to marginalised communities or those in distant homesteads. Overall, there is a clear discrepancy in understanding between the actions of researchers and the needs of farmers. Traditionally, adoption studies and interventions are treated as distinct. But for the purpose of this PhD, I have produced the following infographic. Beginning from the top, survey data is collected and given to scientists to analyse the technology use and resultant impact on livelihoods of farmers. It is then the task of scientists to inform policy makers and technology developers on best pathways to implement agricultural interventions. It is then the role of farmers to adopt these technologies and engage in further surveys and studies to create more data for scientists to continue making more products. What is generally underappreciated in this field is the interplay between both farmers and scientists in generating a sound agricultural food base. In light of the problems I've just described, the key reason for poor rates of adoption in sustainable intensification technologies can be put down to poor data collection and understanding among scientists, leading to ill-informed policy, which alienates farmers and disengages them from participating in future studies. In order to fix this cycle and reconcile the needs of farmers with the actions of scientists, I propose the introduction of two very powerful digital innovations. These are data science methodologies for scientists to better understand and utilize farmer data, and ICT technologies for farmers so that they overcome issues of race and class and geographical limitation and participate and engage in the development of technologies.
I will begin my research by exploring data science. I will be employing the tools known as data mining and machine learning on an agricultural economics dataset. I have been granted the use of an adoption study measuring the uptake of maize and legume intercropping as an agroecological strategy for food security in East and Southern Africa. The project, known as SIMLESA, took place between 2009 and 2019. During that 10 years, 3 surveys were taken over the 5 countries. These countries were Ethiopia, Kenya, Tanzania, Malawi, and Mozambique. Over 3,500 households took part, and an additional 5,000 individuals. These surveys took a far more extensive and detailed approach in comparison to traditional adoption economic studies, covering a broad range of unorthodox social and agroecological variables. I have formulated the following research questions to assist me in my analysis. What personal data is required from farmers that is useful? How can that data best be utilized to explain the adoption decision process? And what is the best pathway depending on a given set of variables for farmers? In employing these techniques, I hope to make adoption studies less data heavy, gain a better understanding of output, and develop typologies that will allow immediate feedback to farmers in the field on how to best improve their productivity and livelihoods.
Following the cycle, I may not have the immediate resources to put my findings into policy and technology and ensure that the farmers get the full benefit of big data. However, by maintaining a good relationship with my industry partners, that is the University of Nottingham Future Food Beacon and CIMMYT, I will be able to put my findings to good use. In addition, I have an emerging relationship with the Department for Environmental, Food and Rural Affairs in the UK, and I intend to build on previous work and engage farmers in my process through a group of UK online farmers known as the Farming Forum. This will allow me to combine both bottom-up and top-down ideas around development and hopefully produce a more inclusive methodology for implementing policy. While it may be easy for me to get in touch with farmers in the UK through this forum, there is very little research on how infrastructures such as these can be utilised in developing countries.
Thus, I propose the following research into information communication technologies. Mobile phone subscribers in Africa rose by 685% between 2005 and 2015, amounting to over 700 million users. While this is currently a vastly underutilized resource in the dissemination of agricultural technologies, pilot projects have shown that digital service provision leads to greater agency among users and parity of knowledge among men and women. It is my intention to explore the potential of information communication technologies and mobile phone technologies and apps in particular for encouraging the uptake of sustainable agricultural practice and empowering farmers with the necessary resources to participate in the creation of new technologies. This will be conducted through a field survey and focus groups in some lesser project countries, exploring the use of a groundbreaking app called Hello Tractor. This is an Uber-style app which connects farmers with owners of big machinery to allow greater use and shared ownership of large agricultural mechanization technologies. I formulated the following research questions. How might digitalized service position make sustainable intensification technologies more inclusive in developing countries? And how can they then be utilized to inform research and prediction models?
The final facet of my framework is the inclusion of personal data and in that, farmer knowledge. In order to produce a functioning food system, it is essential to understand the needs of farmers in order to establish if new technologies are even necessary. It is hoped by including frameworks outlaid in participatory action research and responsible research and innovation, I will be able to include the voice of participants in formulating my data mining and machine learning predictors and empowering them with mobile technologies so that they may continue to play a role in a democratized framework for policy and technology development. Here I've included some of the institutions, disciplines and contributions of my project, beginning on either side with computer science, combining with agricultural socioeconomics. These are centered around the Horizon CDT on the left and CIMMYT and the FFB on the right. I will bring in my previous experience working with technological change studies, sustainable intensification, and rural sociology, and working with my supervisors to expand my knowledge on data science, ICT, and human-computer interaction studies. It is hoped by merging these disciplines, I can make great contributions to the field of dealing with personal data of farmers in the critical context of climate change, growing population, and social exclusion, and then make significant changes to how policy is developed to combat these issues. I've developed the following stages of my project, which hopefully should not be overly affected by the outcomes of recent crises in the coronavirus. But my current activities until the beginning of next year are to complete a systematic review of adoption studies and to begin analysing the SIMLESA dataset. Then next year I will design and implement a survey and do some fieldwork in SIMLESA countries to assess ICT and to validate my prediction model. And then the final stage will be to analyse and construct my thesis and to finish off any possible publications. Thank you very much for listening. I hope you've enjoyed my PowerPoint presentation. Please leave any questions below. Thank you.